Hello, welcome to Taxonomy Online Mathematics. In this episode, we are going to deal with convection from base 10 to other bases. In our previous lesson, we did how to convert from the other bases to base 10. Now, the difference here is that we assume base 10 to be bigger than the other bases, as in terms of digit, the values. That is why base 10 make use of digits from 0 to 9. Now, other bases have their digit as a subset of the digit of base 10. So if I'm moving from base 10 to other digit, the digit has to be truncated. If I'm moving from base 10, let's say to base 5, I cannot use the digit 9, 8, 7, 6, 5 itself. So it means that in order to get that smaller number of digits, with 5 numbers from 5 and above are not included, I need to break down that number with the base, so that the 5 will break every number to give me the remainder of that number. What I mean is that if in case I'm having 9, which is base 10, I cannot write 9 in base 5. So if I want to convert this, I have to divide this repeatedly. If I divide this number by 5, I will get what? 1. What will be the remainder? The remainder will be what? 4. Meaning these digits are in base 5. So converting 9 from base 10 to base 5, I will have this answer as the correct answer. So it simply means that any number given to me in base 10 has to be divided repeatedly in order to produce these digits that are in that relevant word base. Okay, let's take an example and see. We are to write 259 base 10 to a number in base 8. Don't forget 200, even 100 is bigger than what? Base 8. Because if this were in base 8, without this being 4, it could have been 254, not 254. So we need to take the number, break it down by the base, so that the units or the symbols under this will be my remainder. What I mean is that I'll have 259. This is the number I want to break by what? By the base. So I break it down. The base is what? 8. Now when I break this down, I'll be interested in the remainder. Therefore, I have another column called what? Remainder. So let's go. If I use this to divide this, what will I get? Don't forget, this is 24. 3. So, remainder 1. That's 19. How many times would that go into 19? I think 2 times as what? 16, right? Or 2 times? Yeah, 2 times. So, that will be 16. This time this will give me a remainder of what? 3. Because 16 minus 19 will give us 3. So I have 3 as a remainder. Now this is 8 going into this again. How many times? I believe that will have been 4 times, right? So I have 4. Remainder what? 0. This is still under base 10. So I have to make sure 8 divide this. Now when 8 divide this, it will go there how many times? It cannot go. So it goes here 0 times. Remainder what? The single digit, which is what? 4. Let me take it again. When they get to this place, we want all the numbers in this column are in base 10. All the numbers here are the digits that 8 can accommodate. So when you get to this, which is smaller than the base, you still have to find out how many groups of 8 can be seen in that number. And there are only 0 groups. Remember a digit of 4. That's the remainder. So we are going to start, normally we start from the right to the left when you are breaking the number. So you are going to write your digit in this way. Meaning 403 base 8. If you are to convert 259 base 10 to a number in base 8, you'll be having 403 base 8. Alright, another one. So we are changing 19 base 10 to a number in base 2. Base 2 means binary. Base 10 means decimal, numeral. So that simply means that I cannot get 19 in base 2. So I need to use the 2 to divide the 19 in order to have digits that can be accommodated under base 2, which we know to be 0 and 1. So I have my 3 columns, which is going to be the base 10, which is 19, and the remainder. So now this goes into this. How many times will it divide that? Let's take 18. If it is 18, you go there what? 9 times. So 9 remainder what? 1. Because 18 plus 1 give you 19. So 2 will in turn divide this. I believe that will be 4 times. 4 times this, 8. 8 minus this, 1 as a remainder. Good. Then 2 will in turn go here. 2 times remainder what? 0. That's 2 times this is 4. 4 minus this, 0. Then 2 will in turn go here. How many times? 1. 2, 1, 2. Minus this, 0. This is still under base 10. So I need to break the last one. 2. We'll go here 0 times. Always you need to get 0 in order to get our accurate base. This go here 0. This time this 0. 0 minus this is what? 1. So we have the remainder to be 1. So in this case, we are writing our answer as 1 0 0 1 1 base 2. Conversion of 19 base 10 to a number in base 2 will produce this. I believe you get the concept. Changing from, we make it in a way that if you are moving from base 10 to other bases, break the number down by the base to make it smaller, acceptable digit. From the other base to base 10, expand the number to accommodate the place value to involve the digit of base 10. So from base 10 to other base, we divide. Other base to base 10, we multiply. As in, we expand. I believe you get the trick. Good. If you do, then let's see what you can get. 34 base 10 to a base 2 numeral. Let's see what your answer will be. Thank you for watching. Don't forget to share with your colleagues. Like, comment, and subscribe if you are new. See you in the next episode. Bye-bye.